basic communication principles and one last film on communication basics. So we will look at asynchronous and synchronous communication. That is when you have clock pulses to control the communication, and you always do actually, because clock pulses are used to synchronize the sending and receiving part. So when I have a message like this, for example, with ones and zeros, of course they can be schemed in a digital way like we looked at in an earlier film. But you need to tell the sender that this is the start of a new bit, this is a new bit, and not that this is 5 bits, for example. How can a sender and receiver agree the length of a bit and the duration of a bit? So you use clock pulses in order to do that, and the clock pulses are like a metronome to keep the timing between the sender and the receiver. If you have synchronous communication, you have a sender and receiver have a common clock pulse, which means that it requires one extra wire, one wire to carry the clock pulse. In asynchronous communication, you don't have that. You send a message, and from that message, the receiver is able to regenerate and understand what kind of clock the sender had. So for example here, if you have synchronous communication, the data goes back and forth between the two, and you also have a wire carrying the clock signal. While here you have a sender transmitting data, and when it receives the data, it understands the clock frequency and the timing of the clock. And likewise, when data goes back, this part can recover the clock and understand how it is. So in the first example here with synchronous communication, you have one wire simply carrying low, high, low, high, low, high, which controls the speed of the communication. While in the asynchronous, you need to start your message with one start bit. And the start bit is defined, for example, in this case, it's a signal that goes from low, one high, and one low, and it has the duration, look here, it's a bit wider than the others, which means that it takes the time 1.5 times the others, and therefore by doing that the receiver understands, okay, this is the clock frequency, this is where one bit starts and this is where one bit ends, and it's able to distinguish the bits from each other here on the other side. Finally, packet switching and line switching. When you communicate over longer distances, you have two options. You can create a line between the two. So for example here, if this is Bergen and this is Oslo, when you communicate from this computer to this computer, you occupy one route over the mountain to Oslo, while in packet switching you don't occupy one route. You split your message into different small packets, send them individually, and they will individually find their way through to the other side. This requires that you occupy the line the entire time. It will not allow for any other to communicate on the same line, while this one is more convenient for internet-based applications, for example, because you can share the media. When I send a package here, it will find its way through, but in between my packets, others can send packets, and so on. This one means that the packets will arrive here in the same order as they were sent, while in this kind of communication, the packet switching, the packets may arrive in a different order than they were originally sent. However, once the computer here receives all the packets, or when it knows that all the packets have been received, it can start to arrange the packets in the correct order again. So overall, this is a more more convenient way of communicating the way we do in the internet world. For example, if I send a mail from A to B, I don't care really if one part of the mail comes before the other, as long and I will not be able to read the mail until all the parts of the mail have been received. So therefore, packet switching is common in the internet way of communication, while line switching, that was common in old telephone-based systems, where you actually required one string of data to be sent in a correct order.